Good afternoon. Welcome to Kyoto University of Advanced Science Student Robot Challenge 2026. My name is Sajid Nisar, and I am instructor of Advanced Mechatronics course. So this course is our highlight for the spring semester. This course is divided into two parts. In the first half, students take lectures and do hands-on exercises to learn how to build multifunctional robots. In the second half, they design their own robots based on their original ideas and then compete in a student challenge in week 15. So today is the final day. Our 12 teams who have put a lot of hard work to build their robots are ready to put their robots on the field and test them. So we are proud of their hard work, and some of them will work and some of them will fail. But this is the real engineering, unscripted and real life. So before we begin the challenge, I would like to invite Vice President of Kyoto University of Advanced Science, Professor Osamu Tabata, to have a few words.
Hi there. How are you doing?
Good.
Good? Okay. Let me ask one important question. Last 15 weeks, did you enjoy this course?
Yeah.
The voices are not so loud as I expected. May I ask one more? Did you enjoy the lecture course?
We did.
In 2018, when I designed the curriculum of our engineering program, I designed this course as one of the iconic course of our curriculum. And I really want the very best course, not only in Japan, but also in the world. And because of very dedicated effort of our great professors and TAs, and also of yourself, students, I believe, I'm very confident that this course is the best course in the world. I saw the videos you made last week about your performances. What I felt is, now let's see, here is the goal of today's performance, but many of your robots seems here. So I'm wondering, can they complete the course? Maybe you also worried about that, but I believe that you made a lot of effort after 14th week for a week until today. Most of the case, project, here is a goal, here is a starting point, week 1, and week 15, and here's the goal. The progress is not like this. Always a project from my last 70 years, my experience, I would say the progress is something like this. In the beginning, it's okay, but then later it seems not good as I expected. Then at the last moment, it going like this. We say in Japanese, this is last spark. In English, it say final stride or final push. And most of the case, this final push makes big difference. So today, let me show your final push and your good performances. I'm very much excited about. And this course today is streaming. And now I believe 1 million people is watching these courses. and let's show your performance to the world. Okay, good luck.
Thank you very much to Professor Nisar and Professor Tabata, our honorable respected professors, for introducing this challenge to every one of the viewers and every one of the students present here today. I would like to reintroduce what we are doing today. This is the Mechatrolab Advanced Robotic course of the KUAS University Engineering Department.
Thank you. So this is our first live. Thank you everybody for joining it today. And we're here with me, Arujan, and my co-host Faimol. So let's get into it and see what our students have in store for you guys.
Another friendly reminder that this is a challenge course, not a competition. Everyone here is trying to finish the challenge course and not competing against each other. So please keep that in mind to the viewers and all the challengers coming to this course. Thank you very much. Okay, so I would like to quickly introduce what the challenge course has in store for everyone, for the viewers of the live stream. So stage one has few different courses. We have the door, the uneven terrain, the slope, the ditch, the QR code, the cliff, the rollers, stair, traffic light, and object in that order. And the number 10 is what the points they will get for finishing each of these obstacle courses. So I'll go in depth about all of these obstacles. First of all, we have the door. So for stage one, robots must open the door by either pushing or pulling. Leading on from there on, they will go to the uneven terrain. The challenge here is to maneuver the robot through the uneven field while trying to stay within the boundaries that we have set. Following that is the slope. The challenge in the slope is to ascend the slope without slipping. This tests how well the grip of the locomotion system of each robot is. Then we have the ditch. So the ditch is designed for the robot to fall into the ditch and to be able to travel back up. Following that, we have the QR code. So each of the robot is set with a camera, and with that camera, they should be able to scan the QR code and they should be able to publish the output through an LED light that they have connected to their robots. Following that, we have the cliff. This is a fall. You have to jump from the cliff. This will test how rigid your robot is and the integrity of your robot. Following that, we have the rollers. We have placed double rollers which are moving passively in opposition to the wheel or the locomotion system of the robot. So they have to have enough speed to go over the double rollers. Following that, we have the stairs. This is one of the hardest. This is one of the hardest obstacles that each of the students have been facing throughout the trial courses. So the idea is they have to climb up the stairs and climb down while keeping their robots in balance and not trying to tip over. Then we have the traffic light. With the use of the onboard AI, they need to be able to read the traffic light and communicate with the barrier to publish the output and open the barrier. Following that, we have the object. They can either push, pull, or lift the object to a specific point of the course. Now we have stage two. Stage two also has the door, has uneven terrain, slope, ditch, QR code, cliff, roller, stairs, traffic light in that order. But some of them have more points because you have to use your robotic manipulator or the robotic hand that you have designed throughout this whole course to be able to maneuver these obstacles. So for the door, for stage two, using the handle of the door, the robot should be able to 15 points that has been connected to this obstacle. Then there is the QR code. Similar to last round, they will have to read the QR code, but the robotic hand. And that is it for all the obstacles. Thank you very much. Please stay tuned, and I'm sure we have a lot of exciting robots and challenges to see. Moving ahead, we will have our first robot combatant entering the challenge course. Zut?
So we're Team One, and this is our worm bot. We're looking forward to this, like the locomotion mechanism that we made, actually, making traction on the field itself. Because I mean, we've tested it on flat ground a lot, but it's really its own experience to see it actually work on stage. And so, yeah, we're looking forward to actually testing it. So, well, as I think might be obvious, our inspiration was like a worm or like an inchworm, the way it moves and kind of drags itself across the ground. So, yeah, we took a lot of inspiration from that. The most unique feature is that it doesn't have wheels, it doesn't have legs, it doesn't have tracks. It just expands and contracts and somehow still moves. the we went through a lot of challenges, but like I guess a vast majority of them had to do with the fact that this mechanism is just hard to get moving, especially when it comes to like obstacles or friction. So overcoming all of those things, and especially figuring out how to best pair the other mechanisms like the claws with that expansion contraction movement, figuring out the best combos, yeah, that took quite a lot of trial and error. We're confident that we're going to pass on uniqueness and doing something that's very difficult. We're confident that we won't be passing on completing the course, most likely. But yeah, we're going to try and pass both of those things. I think a lot of the parts that have more flat ground, like the part where about the QR code, about the traffic light, opening the door, etc., probably shouldn't have an issue. I'm more worried about parts that, let's say, um, put you at an incline, like the slope or the stairs, because that puts a lot more pressure on things like the claws for them to hold the entire weight of the body, which is pretty heavy. So yeah, quite worried about that. Well, sometimes some projects can be difficult, but even if it doesn't end up succeeding, the process of it is just something that's very, very fun. So don't let that hold you back.
door was opened so confidently.
Yeah, this robot surprisingly has been doing really, really well. As a TA of this course, I have seen this robot struggle. I have seen the highs and the lows of this team. And believe me, last night was the lowest point for a few of the members because they were trying to have this robot constantly move, but they couldn't. Yeah.
Oh,
I personally spent half of my night. I went back home at midnight around 3 a.m. while I was trying to help this robot. Another one of my colleagues, another one of my TAs, did stay here till 7 a.m. in the morning helping them out. But one thing I will say this robot has is tenacity.
do you feel proud of how far it has come?
I am absolutely proud of every team here and what they have achieved here. As you may notice through looking at this course is well suited for wheeled robots, not much for any other locomotion types. And this is a very hard locomotion type, having a crawler, a snake type robot.
I think their first prototype was more of a worm style.
I mean, this is still
Oh,
they have just finished. As we are seeing, they have just completed four of the challenges, which is amazing so far.
it's
They
very
have
good.
30 seconds left, which is very sad. But now I think they will be they will be skipping over the QR code, and they're gonna attempt the ledge. Let's see if the robot is strong enough to survive this fall.
Can it go down?
For the viewers back home, this is a 10 centimeter drop. Might not look big, but for robots that have been slapped together hastily, this is a very hard challenge because this might break the whole rope.
Okay, we have 5 seconds left.
Let's see.
And
And
time over.
time.
Thank you so much, team number one.
Thank you very much, Team One. And I think that is the end.
Hello, everybody. We are Team 2, and we are excited to present to you our robot that is currently work in progress. We are very excited to see our robot running and overcome all the challenge obstacles that the university throw at us. Our robot has 4 wheels, that's 4 driving wheel and suspension system. Our robot is heavily inspired from the rover that's working in Mars, because we saw that the rover can move in very difficult terrain, overcome a lot of hills and stones and a lot of that. So we're trying to replicate that robot that can work on those harsh terrain. The most unique feature of our robots is the suspension system. We have the suspension system to help the robot overcome most of the challenges, except for the few technical that require other mechanical parts. Well, how are we going to overcome a lot of these challenge? So basically, these wheels, they are custom made. At first, we were using a pre-built one. We bought them and we tried them out. The wheel was way too small for our robots. We had to make various adjustments to the size of our robots to overcome a lot of these challenges. Basically, it's bound down to bigger is better. We keep increasing the size and the wheels of robot, and then it's become better. From our testing, we have tried to run the robot in older version of it, and we are very confident on the early stages, the slope. The robot can do that very easily. However, we are currently struggling with the stairs. It's very tall and very challenging. So, if you want to build robot, prepare to make a lot of time for it. It takes a very long time and a lot of your energy to make it, but have fun with it.
So as this robot suggests,
As
it's
of
a
now,
race.
Team 2 has completed most of the challenges. Their novelty with this robot is that they're very fast.
As the name suggests, the racer.
They're now attempting to get the traffic light turned on. Let's see if they can read that.
There's still a lot of time left, so I think they should be fine.
This is usually the task where most of the teams suffer because ROS to ROS connection is pretty hard to make. For the viewers back home, they have to communicate with the computer inside the traffic lights, and they have done it.
Woo!
They have established it. Let's see if
Okay.
they can finish. They have 1 more minute to push the obstacle, push the object into the specific position.
Okay, there seems to be some trouble with the controlling. Right now, it's taking out the. How
They
do you
have a
call it?
hook as a manipulator. I think
Ooh.
that's good enough if they can push it inside.
Uh-huh.
Will we count
Oh.
if it is fallen over and it is pushed inside? I don't know. It's up to the judges to decide.
They're trying to put the hook down to get it to
From
work.
the from the zoomed in view, you can see that the obstacle has fallen over, and they have 20 seconds. Can they push it in?
Okay. Uh,
And I think
we have 10
they have
seconds
pushed it
left.
inside. 10 more seconds. Can they make it stand up? And that is time.
Thank you, team number 2.
Unfortunately,
Hello, everyone. This is Team 3, and we have the 5 member. For right now, we have 3 members right now. This is Nay, this is Ruku, and me, Pyo. And our goals is to complete the most of the obstacle to overcome it, like as much as we can. So yeah, this is our goal for the day. So the inspiration behind this is like we want to use the motor just only for the two, so it will be power efficient and easily controllable. And also, like in the previous semester, we have robotic manipulator class. In that class, we have learned like this clan mechanism. So we want to use it right now, and then yeah, that's a clan mechanism and spider robot. Yeah, mostly our own unit feature is like mostly the clan mechanism just only had the leg. But for our robot, we already added the two wheels here. This is like to increase the stability while it is overcoming the obstacle over there. So yeah, our main target for implying this two wheel is when climbing the stair to increase the stability. That's all. Yeah, the challenging is like, as you know, we use the mechanism over here. We need to calculate the length, this leg length. So to overcome the step, we need to make a precise calculation of the link length and the rocker, yeah, everything. So this is kind of challenging for me. For the like, as I am taking charge of the physical design and like building of this robot, this is from my side the main challenges. As he is the main charge of the software, so he will be have some challenges.
Okay, I'm Nate. I'm gonna explain about the challenges we face on software sites. So, here, our robot is like autonomous driving systems. So, we need to use the camera for detections, like object detections and line detections. So, here we use the Raspberry Pi 4 and then Nucleo microcontroller mainly. So. The main challenges is like here in our project we are using ROS2, which is like robotic operating system 2, which is very powerful for robotics. So there like unlike the other platform like which have like only one file of codes like for controlling the whole body. In ROS 2 we have different nodes for each different detections. So like we need to split different nodes, and then we have to in each node we have publisher and subscriber files. So like we have to handle all the file and the like all the directory on ROS 2, so which is very challenging for me because like we have only experience of like using one file of code. So here ROS 2 we need to use a lot of files, we need to handle everything, and then we need to we need to let the microcontroller decide which nodes to be run. So like those are like my challenging part in software things. Our robot is confident in the overcoming stairs and the slope and then and even terrains because we are using the lag and then the weight as well for balancing our robot. Um, we've got a little bit worried about the how to say the very high jump. So like for example, there in our task area we have a uh, very high jump. So we have to like climb down like immediately, like without failure. So like that is will be the main challenging part for us because we are using lag and we. So like we have to make the robot balance, and then we have to come down. We have to like jump down the smoothly. So that would be yes.
Yes, we are trying our best to learn everything about the robotics. Yeah, so everyone also do your best in your field. What are your professions? So do your best in your field. Fighting.
Okay, it seems that the robot is still not ready. Are you guys ready now? They are ready. So I think we are ready to see the movements in this robot. Unfortunately, this robot seems to be struggling at the start.
Since this course is made for the wheel robots, this one is having more of a harder time completing it.
Yes, this robot is has been using a very unique walking mechanism, which is Clint's walking mechanism, and I think they're going to cancel their attempt since they're not ready.
Okay.
Hi, so we're Team 4, or otherwise known as Team Hail Mary. So for today, we are presenting our robot. We actually made Rocky from Project Hail Mary, as you can see here. Honestly, we hope that we can bring Rocky to life and as well as completing the entire course because making this robot has been a challenge for each and every one of us, and each of us has been working so hard just to make this as it is today. So
So before we actually arrived at the idea of Rocky, we had like a few other iterations, and one of the the first idea was a scorpion, but I think the group already agreed that we do want a crawler robot, and I think the movie actually released about the same time when the project started, and so we all watched it. We all felt very inspired after watching that movie, so we just like ultimately decided that maybe instead of the scorpion, we'll do Rocky, and besides Rocky would be like a lot easier to build compared to like the scorpion idea since the scorpion will have some claws and pincers that we think would be a bit difficult to accomplish, and we do want to make the robot simpler so that it can be more realistic for us who's still learning while being able to like actually finish it and make it complete the entire course.
One of our most unique features is the fact that it has 5 legs. A lot of robots and a lot of designs in nature are with 4 legs or 6 legs or 8 legs, some kind of pair. But with it having 5 legs, it is quite unique, and we think it's going to be pretty different compared to many things. So me and Michelle, we were doing the electronics of the robot, and one of the most difficult things about this was designing how the electronics should sit and how they come together, and also from now on as well, making sure that there's no problems with the electronics, no short circuiting, no electricity getting in the way of the robot working. So that was probably the biggest challenge for the electronics.
what Algatan said is true because sometimes from the outside it looks okay, but really after we use the multimeter to actually check, like, oh, there's a continuity between the positive rack and the negative rail, which is not supposed to happen because it's gonna short. That's why we have to check it. And when I soldered these with Algaton, it was such a tedious like task to do because I have to make sure each of the buck converters are all correctly aligned, and it has to be sequential based on which buck converter is being used for which part of the robot. So it's like the front section and the back section as well. So there's a lot to consider, but we all honestly worked so hard on this. So
As we haven't tested yet, I mean, we haven't tested enough to know if we're really confident about getting through the course, right? I think the only thing we can say that we are going to confidently get through is the uneven terrain over there. We will most probably be able to walk straight over the uneven terrain, really, because I think we can get over the ledge, right? As long as there isn't any weight balance issues and there's enough friction for the legs to possibly like anchor over to get through the course, I think we'll be able to get through a lot of the course without many problems. But only testing would tell.
that's true.
Well, if ever you guys are interested in robotics and just making your dreams come alive, similar to how our Rocky will come alive, and then hopefully in the next week, well, join KUS and join ML3. You know, it's a fun experience.
I also just want to add that I think one of the main things that we learned from this is that you shouldn't be afraid to try something new. Since all of us were also inexperienced when working with Rocky, this is also something very new to us, and we still did it anyway, even though we knew it was going to be quite difficult. So yeah, that's my message: just don't be afraid to try something new. If you're really interested, you should pursue it. Don't give up. At first, keep going until the end.
For our viewers online, everyone is watching this robot's performance with bated breath. This robot, if you might not know, is inspired by a very popular character from this year. For all the film fanatics, you might have noticed the name and you already know what I'm talking about. This is Rocky from Project Hail Mary, or at least inspired by it. And team Team 4 here has really worked really hard to make this robot come to life. As you already know that this course is made for wheeled robots. This is very much advantageous if your robot has wheels, but it takes a lot of courage, it takes a lot of bravery to have a walker robot and come into this field. And in a way it portrays the idea of the movie itself, where the astronaut is very brave or very stupid in his ideas to cross the galaxy to save their planet. And this is Rocky is truly showing that spirit.
Also, to mention, all of the robots that you've seen previously are teleoperated, which means there is a person operating them, which you can see on the screen in the bottom. So we
It
intervene
seems
here.
that Rocky just got a huge intervention and skipped over skipped over the slope and the ditch.
Yeah,
And
if
now
it-
Rocky is trying to, I think it has, they have lit their LED. And another one, another intervention, Rocky will try to walk over the double rollers now. Let's see. During the practice round, Rocky was able to do it. We have 10 seconds.
Okay.
4. And that's it. According to the judges over there, Rocky is out of time. It seems this Rocky did not save its planet. Thank you very much.
Hello, we're Team 5, and we're looking forward to fully completing the course. So the inspiration for our robot was originally based off of Wally. So as you can see, it's a tank-based design. with a robotic arm on top. One of the unique features of our robot is that it will be fully 100% autonomous. Both the actual robot itself and the robotic arm on top of it will be 100% autonomous. So we had a few challenges, but to sum it all up, I would say the main challenge when building the robot is really just putting everything together, right? Getting the motors to work, but then integrating it all with the camera for the line following, and then the whole circuit together. So basically integrating everything together. So once we look at the track, we're pretty confident about climbing up the stairs. Our robot has pretty high torque, and due to the tank design, it is able to climb up the stairs quite easily. However, one of the things that we are a bit worried about is going down the stairs. So since the robot is quite heavy and it could have a bit of weight at the top, we're a bit concerned that it might tip over once it goes down the stairs, but we're pretty confident going up the stairs. Like even if you have no experience, you can still build a robot. Just lock in and go for it.
Unfortunately for the viewers back home, the beast is not moving, so the beast needs a bit more time to get out of its slumber. So they will be skipping over to the next team.
Hello, we are Team 6, and on the day of the competition, we are excited, or we want to at least try to finish the course. So our robot is based on Perry the Platypus from the Disney show Phineas and Ferb. Our unique feature is our locomotion, which is a two-legged walker. So it will use these legs to kind of do discrete steps, and I guess our beak slash arm design. Main challenge is our locomotion. It sometimes gets stuck, and it sometimes doesn't move how we want it to. So we're trying to fix that. I want to say that we can get past like, yeah, the traffic light part, but we are kind of worried about the stairs. I guess, yeah. Yeah. Yeah, this class is like really fun. You get to make your own robot, and yeah, you could kind of do kind of whatever you want. Make not like whatever you want, but just any unique idea you want to make, and yeah, you can make something unique like this. So if you kind of want to make a robot or are interested in this kind of stuff, I think this will definitely be a good university for you.
Okay, so we're here with the Perry the platypus. It's doing very well so far. This robot is a skipping motion one. So again, we've seen a lot of different implementation instead of wheels. So this one is using motors to rotate its tiny cutesy feet to move forward. And we had a little of a technical problem so far, but the Perry itself is doing very good. It's stuck right now at the rampart, but let's see how it goes.
Also, again, sorry for the disturbance with the camera. It's a bit of a hardware issue. I'm so sorry for the viewers watching back home. We will try to fix it as soon as this round is over.
Okay, it's moving. It's stuck.
It seems Perry is Perry. I'm sorry, Perry. For legal reasons, his name is Perry. It seems Perry is having a bit of trouble trying to go up the slope.
So we can see here that in this course you have full freedom to create the robots you like. You can choose your characters, as we can see here, and I think it's a very nice one and something cute to do.
Hopefully, Perry gets over this. I think they're trying to have an intervention, and they have intervened over the slope. Now Perry is trying to enter the ditch. Let's see if Perry can get out of this.
It seems to be stuck again. Okay, 10 seconds left. Will Perry be able to do it? It looks like it's swimming. Okay, thank
And
you.
that's it for Perry the platypus. Thank you very much.
Hello, everyone. We are Team 7, and this is our robot Big Boy. What we want to do with Big Boy is hopefully complete the full course properly. So, the main idea for the design came from her, and we really liked it. So, we decided to go with this, I guess, bigger, kind of like a cube ish form that I think is really unique and cute, simple, but also unique at the same time. So yeah. Ah, our main feature is well, you cannot see it right now, but here it's supposed to be a big wheel, which is basically the main movement for this robot, so it can steer and it moves forward and backwards while having these two passive wheels just supported. So, and we also have a very intelligent camera that is the eye of the robot. So I have to say, of course, the integrating the hardware and software parts was difficult enough. But since our main feature was the main big wheel, I think that was the hardest part in ways that we had to assemble the drivetrain, test the motors properly, and adjust the positioning. So I'd say that was the biggest of all the problems. But we had some other minor problems as well. We are confident that all of the features and stuff we programmed and made the robot to do works separately on its own. But since we haven't tested it out yet on the field, we are not quite sure if it's gonna go the way we intended to go. But judging from what we've tested out so far, we are pretty confident it should go as planned. So please support Big Boy over here. We really want him to succeed. We really want him to go and crush the competition, even though we still haven't tested out. But I think this has been a wonderful opportunity for us, and we would be happy if you could support us. Thank you.
Okay, it seems that Big Boy is having big problems with small obstacles. According to Big Boy's creators, he has a fresh cut on, and let's see what he is able to do now. It seems the creator has intervened, and Big Boy is gonna try the slope. Come on, Big Boy, I believe in you.
I think his big body is making him slower.
Big Boy, small energy. From the pre-run interview with the creators, the only comment the creator had was,
Big boy. What about big boy? Big boy.
he is just a big boy.
Yeah. doing big things.
Okay, big boy just skipped over the slope. Now he's trying to attempt the ditch. Sadly, unfortunately, for the viewers back home, it seems Big Boy does not have enough torque to get over these obstacles. I'd like to mention again that Big Boy is teleoperated, one of the teleoperated robots that we have here. So let's see if Big Boy can at least read the QR code.
10 seconds.
10 more seconds for Big Boy. Let's see if Big Boy can do this.
Big boy.
Unfortunately, it seems like the obstacle was bigger than Big Boy. Big Boy, bigger problems.
And he's getting a big thank you.
Okay, hello everyone. We are Team 8, and we have 5 members in our team, starting with Elnor over here. Then we have Yashvin, then we have Chinggis, Pal, and me. You can call me Nain. And what we are most excited about is completing the robot challenge in record time. I believe our robot design was in fact inspired by Mars rovers, which is pretty apparent considering the wheel designs that you can see over here. They do seem to be meant for all-terrain moving as well, and I would say that was a pretty big inspiration from our side. I think one of the coolest parts about a robot itself would be the turret over here, because this actually has the capacity to move in 360 degrees. And the reason why this makes a robot unique is because whenever it needs to say pick up a payload or perhaps move something, the whole robot can remain stationary, while the turret is the only thing that has to move around. And not just that, the turret, you can see there is an extrusion mounted on top of it. This will allow our claw to go up and down, giving us 2 different degrees of freedom, which I would say is probably what makes our robots so unique. Oh, there were a couple of challenges actually. First of all, the wheels over here, as you can see, these are 3D printed and they are custom designed. So the initial wheels that we tried out turned out to be a bit too small for the climbing part of our course over there, which caused us to design wheels that are much more thicker. And eventually we had to change the chassis to accommodate these larger wheels. So it required a bit of testing, but I believe we are confident that now these current wheels will be able to accomplish the tasks. What do you think, guys? I think it's safe to say we're confident about everything, aren't we? And one thing we might actually be nervous about is that our robot might just be too fast. So yeah, we'll have to see how it goes on the day itself. Well, we hope our robot can inspire you guys to pursue engineering in the future so that you can make even better robots than us in the future. So yeah.
Okay, ladies and gentlemen, watching from online, this is one of the most prolific robots we have seen so far today. And Echo, as the creators have named it, is quite fast. Now we're seeing the first robot to attempt the stairs, and it has done it beautifully. Now let's see the descent.
Just now asking creators to add any comments. Even though this is not a competition, they said they are planning to win this, so they seem to be doing pretty nicely.
Okay, let's see. Let's see if the communication works. The light is green.
I seem to have missed the moment they read the QR code.
Their lights are on, so they did.
Oh.
They have definitely read the QR code.
That's very fast.
Echo has lost a bolt. It seems Echo is struggling with the traffic light. The issue here is that the robot needs to be perfectly aligned with the traffic light to be able to read it properly.
Oh.
And for the viewers, again, Echo is teleoperated. We have an operator sitting in the operation station. If you can see through the camera, and they're trying to maneuver Echo perfectly to be able to read the QR code.
Hmm.
I'm sorry, I misspoke. It's not the QR code. It is actually the traffic light that they're trying to read.
Is it supposed to catch the moment the light turns green, or?
The moment the light turns green, the AI inside that they have installed will
Mhm.
recognize that it is green and send a message to the judges, one of whom get the printed output which says green.
Oh.
As soon as they see that, they will let the barrier open, and Echo will be able to move forward.
Hmm.
Well, it seems that Echo has calmed down quite a bit after a very prolific start. They had a burst of energy, and now I think they're gonna be skipping over and they have skipped over the traffic light.
Oh.
Let's see, let's see Echo trying to push the object inside. Oh, I think they're gonna use their manipulator for stage one, which is technically not necessary, but um, they have toppled over the object. Sorry
They
to say,
seem
they
they're-
won't get the obstacle point for the object. And that is the end of the course for Echo.
Thank you, Team 7.
Are they?
Hello, we're Team 9 and we're excited to introduce you our robot Spine Bender. So we were inspired partially by tanks and partially by crawlers. So this robot can do both. It's a tank that has tracks, but it can also crawl due to its bendable spine. It can crawl up obstacles and down obstacles and over walls and such. So the most unique feature of our robot is its bendable spine. Thus we gave it the name Spine Bender. It can bend concave up and concave down in order to go up most obstacles. And it can, when we release the torque in the joints, it becomes a passive joint, so it becomes flexible, but it can also be active, which means it can push itself up and down obstacles. I think the highest obstacle we went up was about 20 centimeters, like almost a wall. It can crawl up almost anything. A challenge with friction at first. So these tracks are 3D printed and they're very slippery. So it's hard to see because it's all black, but we cut and glued rubber onto the tracks so that now it can grip the floor and uneven terrain. And like now it perfectly navigates most flooring, most surfaces. Now it has enough traction. Overloaded the servos here in the center a little bit because our robot is really heavy, has a lot of screws, a lot of material, and we held it on for a long time. And yeah, for about 5 minutes we left it on and we went about doing some other things. And when we came back, we disconnected the power, we reconnected the power, and they just went up.
in flames. But thankfully, we disconnected it early, so no casualties. Everything was fine.
Personally, we are confident about everything. We just need a little bit more testing and we need to get a grip of the control. And this robot can do everything, so we're confident it's going to clear the whole track. Yes.
You want to create some kind of a robot, make sure that a tank's going to be a very good idea of you. Thank you.
So, Spinebender, as the creators have named it, has been so far doing everything very smoothly. This is a bit different from the Spinebender I knew. Spinebender has blinged out, has a lot of tattoos on their body, and they have successfully gotten off of the stairs with impeccable timing as well. Spinebender is doing really good. Let's see if Spinebender can read the traffic light. As you may know, that Spinebender is also being teleoperated. The novelty about this robot is it has two different segments being moved with servo motors, so it can move around and maneuver through different obstacles. And they have successfully opened the traffic light. Let's see, Spinebender is the final stretch. Can they bring it home? As long as they push it inside the box, they will get the point.
Push the thing inside the box.
Let's see if the operator can perfectly put it inside. Oh, that is too far. I don't think they can put it inside the box now.
They still
But
have
they
half of
have
their.
ample time to do all of these things. They have breezed through the whole course.
I think they will try to pick it up with their hook this time. Oh.
It seems the operator is trying to put the robot in a perfect place to be able to pick it up. I think they are trying to show off their manipulator capabilities in stage one, which is the second time we're seeing it. Let's see. It's almost there. It has barely missed it.
Oh no.
And the obstacle has toppled over again. This is the third time we're seeing it. Let's see if they can pick it up. I think they're just trying to drag it over now. They have around 1.5 minutes. Oh, they stood it up again. Oh, okay. Props to the operator. They are doing really good, and they have toppled it over again. Never mind.
Oh, I think they
Well,
can
I
move.
think they're trying to drag it inside with hook or no. Let's see. Almost there.
Okay.
Just a bit more if they can go forward. That and they have done it. It is inside the box.
And that is time.
Spine Bender has completed the first stage beautifully. Thank you very much.
Hello, we are Team 10. The, we we looking for to complete the course.
Our inspire is Caterpillar robot. Our robot's unique point is arm. This arm.
Our challenge is this robot is uh, we first we try to make a spider robot, but this is difficult and need more special skills. So we change the whole design. This is very uh, important problem because we have no time. So this is our most big problem, and we will overcome to uh, increase the class time. We come 2 times on 1 week. Uh, we proud of our caterpillars. Uh, this can uh, this can move smoothly on bad road, but uh, this hook is not have strong power. So we worried about the open the door and catch some items. Making a robot is very difficult because that need programming skills and make a logic circuit, some special skills, but it's very funny. So and I'm not alone. We can try to with my team member. So we are enjoying this class time.
So right now we have the Caterpillar hook robot. This robot is special because this team is completely made out of Japanese members in this course, and they have showed incredible tenacity with their robot. Unfortunately, it seems that the body is not taut enough for the tracks to keep in the body, and it keeps on falling off. But they have successfully completed the door, the uneven terrain, and even the slope. I don't know if our judges will be counting it yet. So they're still waiting to finish it, and they have done it. Let's go. Big round of applause for Caterpillar Hook. Next, they will be tackling the ditch, and it seems they can do it. Well,
One of the wheels is stuck again.
unfortunately, it seems their width is exactly the same as the ditch. They're trying to fix the wheel again, the Caterpillar tracks again.
Mhm. Aw. Another maintenance break for our Caterpillar.
Let's see if
Okay, let's see if we can complete the ditch now.
it is having quite a hard time trying to get over the ditch. It seems the ditch is the problem, the biggest challenge for this robot. I think, oh, unfortunate. Really unfortunate.
And it fell off again. So this robot is also
Try QR code.
teleoperated as all the previous ones.
I think they're going to be moving ahead to do the QR code.
Okay, 10 seconds left.
10 seconds left. Can they?
Hey, it did what it could.
And
Thank
that
you.
is the end of the line for the Caterpillar hook. It seems they gave it their best, but this track is cruel and it will take the best from the best. Thank you very much.
Okay, so we're Team 11, and we would like to introduce our robot. And currently, we are excited about two things. And first is that we've made this robot fully autonomous, so we'd like to finish this course fully without any human hand. And also, we're pretty excited to get an excellent score at this course.
The robot is inspired by the capability of it being able to climb the stairs without any additional servos. So we're using something called PATS wheel. It stands for passively transformable single wheel. So if you see over here, the wheel is able to transform, and on the stairs it will be able to climb properly.
Okay, so another unique feature is that what I've mentioned earlier is that we're planning to make it fully autonomous. So this course is meant to be prepared for semi-autonomous, but this time we'll be using LLMs to make the whole vehicle autonomous without using any teleoperation from the human.
So there are three challenges provided by the professors. So being able to get a perfect score in the first and the second round of the course, and then at the end to be able to run this autonomously and get all of the bonus points.
So what makes us confident about is that we've already practiced this course several times with um, a, a practice chassis. So we are very confident with completing the course. So our maybe final challenge is not to be nervous and try to put things together.
Enjoy the show. There will be lots of interesting robots.
It seems that we're having internet issues, so they are not being able to teleoperate it properly. That is why the robot is stuck there. So, I think they can move again. Contrary to what they said in their interview, they are actually teleoperated. It seems the autonomous movement was not properly done. With some lost time due to internet issues, unavoidable circumstances, Tomoe, previously known as Team 11, seems to be doing really good with the task. They have completed the door, the uneven terrain, the slope, and the ditch smoothly. Now they're trying to read the QR code. Let's see if they can do it in record time. It is, they have read the LED successfully. The LED has lit up. Now they will attempt the ditch. I'm sorry, not the ditch, the ledge. It seems the judges have renamed the ledge as the cliff. When I made it, it was known as the ledge. And it has smoothly gotten over the cliff obstacle. And now the next challenge for this robot would be the double rollers. With around 2 minutes left, can they finish the whole course? I'm sorry to the viewers back home. Due to the server issues we are facing, the timer is not showing correct time. But this is also another disadvantage that the teleoperators need to overcome. Now comes the most interesting part of this robot. For our aspiring engineers or who are already engineers back home, this robot uses PATS wheel. This is a passively transforming adapting wheel, and this is the reason they can get over different type of uneven terrain, and they have completed the stairs beautifully because of the wheel. Now let's see if they can read the traffic light and finish it within 50 seconds, give or take. It seems with the timing they are at now, cannot be the current first place, the spine bender. And can they do it? 5, 4, 3, 2, 1. And it's time. Unfortunately, they could not do it. Come away. It's time for you to go away. Thank you very much.
Hello, we are Team 12, and we will be introducing our robot that we have been working on this entire semester. So, what excites the team the most about this robot is that we can finally show what we have been working so hard on.
What inspired us to create this robot was its small design and its spiked wheels, especially its raised chassis for high ground clearance, which we believed enabled us to overcome most of the obstacles, and it did. And just to a brief introduction of our team members, I am Monish. This is Ayat, Abdullah, Kat, and Daphne. The most unique feature would be the claws. Although these clawed wheels, although at a surface level it looks like a four-wheeled robot, a bit basic, these clawed wheels enable us to overcome most of the obstacles, as well as this raised chassis height gives us a lot of ground clearance. So, like unlike traditional four-wheeled robots that have access to turn around, ours turn around by just rotating the wheels in opposite directions. To start off with the wheels, we had to create different dimensions, different sizes of the wheels. Like some were four clawed, some had six, some were small, some were big. We had to do a lot of trial and error to see what fits for our robot or what fits for this course. Apart from that, the chassis had to go through a lot of redesigning. We originally had a big chassis, but we couldn't turn, so we had to make it smaller and smaller, and making it smaller meant that we had to make the circuit smaller. So both sides, people who worked on the chassis had to make it smaller, and when they made it smaller, people who worked on the hardware had to find new ways to implement the whole circuit in the small robot. But luckily somehow we were able to fit everything in the small box.
Actually, we are very confident about almost the entire obstacle course. The only one that we are a little bit worried about are going up the stairs. But we are definitely working on that.
Apart from the stairs, we also have a bit of difficulty with the door, but we will be able to overcome the door definitely. The stairs, we are able to go up the stairs once or twice, but it's not consistent. We hope to overcome that.
Well, the only sort of comment I have basically is it is fun when it works. So, like, most of the way until now, it wasn't fun, but like, it's getting close to being fun. So that's the only comment that we have from our side. Thank you.
So right now we have Team 12, the final team of the challenge, going in with their Ellie bot, and they have finished the first four obstacles swimmingly, I might say. They're now trying to read the QR code, but it seems they're having a bit of an issue trying to read that. So for this robot, when they are successfully able to read the QR code, the green LED on their body will light up. We have the whole room sitting here, standing here with bated breaths. Let's see if Elibot will be able to do it.
It seems to be taking the time to read the QR code.
I think they're canceling the LED and they're gonna move on. For a robot called Elibot, it skipped over the LED. Let's see, Elibot as well. No,
The hook came
Elibot
out.
has a big fall. It seems they lost their hook, and they have finished the ledge, the cliff, I might say, properly. They're now gonna attempt the double rollers. And Elibot is trying to figure out the movement, the correct path to get over the stairs. This robot is teleoperated. Now they're trying to move as you can see, the manipulator. They move the manipulator ahead so that they have more weight in front, so there's a bit more balance. It seems the reason this bot is called Elibot is because of the manipulator, which is acting as the elephant's trunk. And they have finished the stairs.
This robot doesn't seem to have like a clear back and front, right? Because I see it rotating all the time.
Now Elibot will try to read the QR, read the traffic light.
I wonder what the wheels are made out of.
So the wheel is a specific wheel they have used. It looks like a Japanese chakram, you might think. So it is using TPU, which is a soft material. So this wheel is soft but rigid enough to not break under pressure. And this robot with his body shaped like this is specifically made to skip up over the stairs and do the uneven terrains properly. I think they are skipping they are skipping and they have gone through, and it seems they are destroying the field right now. And let's see if Elibot can. Elibot, if you noticed earlier, during the cliff, lost their hook, but they're still trying to lift the obstacle over. They're gonna use the trunk to push the obstacle into the box. Almost there. Let's see.
Okay.
And they have completed it.
Thank you, Alibot.
And that is it for stage 1 challenges. All of the robots have gone. Okay, everyone, please settle down. All the challengers and the viewers of the live stream. I'm gonna go down. I'm gonna completely summarize the position, the rankings. I know I said that this is not a competition before, but we did still do rankings because we are giving points. So let me preface this by saying you get 100 points from the field and an extra 40 points from the instructors of this class, the professors. They review they review based on originality, teamwork, and what they have seen throughout these 15 weeks. So going from bottom to top, we have in number 12, Team 5, the Beast, with a whopping 25 points. Can I get a round of applause for Team 5, the Beast? Moving ahead, we have in number 11, Kumosuke from Team O3 with 33 points. A huge round of applause for Kumosuke. Going ahead, we have the Hail Mary, Team Rocky of Team 4. They have 35 points. Thank you very much. Please, round of applause for them. Moving to the ninth spot, we have Big Boy from Team 7 with a whopping 36 points. Round of applause for them. At number 8, we have Perry the Platypus with 42 points. Huge round of applause, please. Now, number 7 is the Worm with 46 points. Please clap. Come on, you don't need me to tell you to clap. Please clap by yourself. At number 6, we have Caterpillar Hook with 48 points. And now, the top 5. At number 5, we have Team 12, Elibot with 108 points. Moving on to number 4, we have Tomoe with 111 points from Team 11. And now, the bronze spot goes to Echo of Team 8 with 123 points. In the silver spot, we have the Racer from Team 2 with 131 points. And now the moment you all have been waiting for, at number 1, the gold spot. We have Spinebender from Team 9 with 136 points. Huge round of applause. And with that, we have the end of stage 1. Everyone, please settle down, take a break, whatever you want to do, work on your robot. To the live stream people, we are going to come back with stage 2 in a bit. Please enjoy the live stream. Thank you very much for your attention so far, and I hope we can surprise you even more going ahead. Thank you.
We'll resume in at 2:30, so in 8 minutes. 3:30. I meant 3:30.
Okay, to the viewers and the students and challengers sitting over here, we are about to start stage two. As you may remember from earlier, stage two is where they will be using their manipulators, and some of the tasks have been changed. So they will have to open the door by pulling it only. They cannot push through, ram through that they have been doing in stage one. And moving ahead, they will have to flip over the QR code, which you will see most of the robots try, and I hope they succeed. And then they, before the rollers, they will pick up the object and they will have to carry it all the way to the home base, which is at the end of the course. So with that, we are about to start stage two. I hope everyone is ready for whatever we have in store for you guys. Is team one ready? All right. So the operator is in the station. So let's flip the camera over to them. Thank you very much. Okay, so as you guys may know that right now we're doing stage two. For this round, we're doing something pretty special going ahead. After each run, we will not show their pre-recorded interview videos, but we will be doing a post-game interview where we're gonna ask the operators and the team members if they wanna, if should they join, that how they felt throughout this whole course and how they felt throughout this whole class. Right now, the worm is stuck at the same position it was stuck in stage one. It seems that the back incher or whatever, the back claw is not long enough to push it over the slope. This is something that I think they did not foresee coming. As a TA, I did not foresee this coming as well. So let's see what goes on. They have completely skipped the ditch and the QR code. Now they're attempting the cliff. For this robot, they need to use their back claw because the front claw is completely useless right now to move forward.
Okay, we're stuck now. The struggling is stopped also.
I think if they tilt their manipulator ahead, I think they can gain enough weight to go ahead.
There seemed to be an issue with the controller though.
It seems that the operator is saying that their controller has died. I think this is the end of the road for the worm. And that's it. Thank you very much for to the worm for giving us good memories.
Experience.
We had a lot of fun, working for about 10 weeks on a robot. Learn a lot, experience a lot, and honestly, I have no regrets.
What do you think was the hardest part of the whole course?
Personally, for me, the hardest part was pulling the door open because all of a sudden our arm just decided not to move anymore. And then, what about you, Hamza?
The hardest part about the course, I would say, uh, would probably be the stairs. But the fact that we didn't get there is kind of sad. But for us specifically, any turns were a big problem because at the end of the day, we weren't able to get the bot to turn properly, and so anywhere where it required a turn, we just had to intervene, and that really sucked.
So would you say your expectations were completed, or did you do better or worse?
Honestly speaking, our expectations were just to get a locomotion of a worm onto a robot, and we were able to accomplish that. Although yes, we weren't able to take into account how the robot will properly turn everything, we were able to meet our goal in terms of at least movement. So we at least I say we had no regrets. Do you have any regrets?
Yeah, no, because like I want to highlight for most of the majority of the weeks, we were just moving like this, like forward, backwards. We couldn't get a forward movement.
Yeah.
So the fact that we got that, but also enough to get through a few obstacles, like that just like way more than
And also
we
to
could have
mention,
expected.
yeah, and also to mention, there has never been a locomotion designed like this before, right? So we're honestly really proud of it.
So do you have any more comments to add to your performance or anything overall?
Overall, although our group won't be in the scoreboard for the first part, and we're seventh place in the first one, and second place. No, we're zeroth place in the second stage. Honestly speaking, this was a very fun experience, and we have no regrets.
Also, about the second part, what happened to the controller right there?
Honestly speaking, we have no idea why it died. Like we got to the ledge, and then nothing wanted to move anymore. So we just knew something probably happened with the raspberry, maybe a loose connection or something. But we're gonna recheck the robot again later to see what really went wrong, and we're gonna analyze it from there.
Okay. Thank you so much for your time and thank you for taking the course.
You're welcome.
Thank you.
For the LED to turn on so we can move on to the next obstacle.
Okay, the QR code was seemed to be completed, so now we're next to the cliff. Let's see how it tackles this problem. Perfectly fine.
Now they have to do for stage 2 the specialty where the obstacle, contrary to stage 1, is now right here before the rollers, as I introduced during the segue.
That does mean that they will have to complete the rest of the course while holding
So
their
now
obstacle.
they're trying to put their hook in. It has fallen over. I,
They have 30 seconds
they
left.
seem to have skipped completely over the object, and now they're stuck in the stairs. They have found themselves in quite the predicament because of their size. They are perfectly stuck in between the stair and the divider. They need to somehow maneuver to the, and they have done it. And let's see if they can do it. You have 10 seconds left, and it seems Racer has gone mad, and that is the end for Racer.
So now we'll move on to the interview part.
Thank you, ladies and gentlemen. Ladies and gentlemen, we are here with Team 2. All of them have showed up to give us a bit of their mind. So, first of all, congratulations. You have successfully made the robot as your TA in this class. I am very proud of what you guys have achieved. So, first of all, what was the obstacle that you were looking forward to the most?
I think all of us can agree that the obstacle that we looking forward to the most is the stair, right?
Yes.
Yeah. We are struggling a lot with the stair. Spend weeks on it.
Unfortunately, it seems that for stage 2, stairs was your downfall where you guys couldn't get up. From my perspective, the robot looked a bit too wide. Was that a design choice, or was that something that you guys committed to and couldn't really change after?
Well, our initial idea was we made the frame of the suspension too wide, so we were about to change that, but with the amount of time that we don't have that much, we then proceed to the frame of the board.
And also for the ties as well, because at first like we use the tie with diameter only 60 millimeter, and finally we just is right now is 150 millimeter. So yeah.
Okay, so what was something that was unexpected throughout this whole course or this whole class, even? Like, throughout this whole class, I know you guys all changed a little bit with the classes each week. So, what was something that was the most unexpected but welcoming?
Unexpected but welcoming.
We didn't expect to like finish the first course in like 100%. We didn't expect that to happen because yeah, 'cause we only well, first initial we talked together like we were about to skip the stairs at first and then Pontus go for it.
It was like we weren't sure that we test each course individually, but we never have a full run before. That's why completing the first stage, 100 point was a bit surprising to us.
All right. Thank you very much, Team 2. We'll be moving on.
Thank you.
So now I have just gotten word from the operators that Team 3 is skipping, but we will be doing the interview for Team 3 going ahead. So, can you stop it?
Hello, everybody. So we're here today with team number 3. They unfortunately skipped the second stage, but we still wanna see what the robot is about. So, what would you say is the hardest obstacle today for you?
Today is I would say like the body mechanisms. Like we are using the clamp mechanisms. So like we have a lot of issues in the joints, links, and gear wheels because all are printed, 3D printed. So like it's kind of like fragile, and then like it cannot resist to motor speed and it's make broken.
So, why did you choose to go with this design specifically?
Oh, so as I first said earlier, like previous semester, we have learned the introduction to mechanism that subject. So in that subject, we know the clan mechanism is it. So we want to try testing develop that clan mechanism, and so we choose this mechanism.
Thank you. So, what was the reason you didn't go for the second stage just now?
As I mentioned earlier, because our robot shaft and the gear is not aligning properly, so like it's not like making the robot move. So that's why we have to skip this stage 2.
Okay, so about the course itself, what was like the hardest part of like building the robot or just like teamwork?
If you find a good team, that would be very very good opportunity to have to build the robot like whatever you like it, and you can design, you can make it. Um, for as a team, the hardest part is like this bodybuilding for us, like because we are doing the all are 3D printed, and then we make design. We have to make the this kinds of length of the leg because we have to climb up and climb down something like that, and we have to skip some kind of pillar disturbance something like that. So that is what we
Do you have any additional comments to add about anything in general?
do. Oh, in general, okay, if you like robots and things like that, programming, something like that, and ROS2, which is robot operating systems, if you like those kinds of things, this class is the best choice.
Okay, thank you for your time. So we will be moving to team number 4. Thank you.
I want to apologize. It seems we have not been listening to our dear viewers who are commenting constantly. And don't worry, I have a live feed of the comments right now, and I will be checking more often. So right now, Rocky is trying to save the planet again. This time they're trying to pick up the object. Let's see, Rocky, you have a lot of fans online. Everyone is hoping for you to win. So let's see what you can.
The claw is actually
Almost there.
open.
Almost there. If Rocky can grab it, it can pull it up. Can Rocky do it? We are all waiting for Rocky. We're getting another intervention.
Skipping the stage again.
Yeah, so they're skipping over to the traffic light. Rocky, a fan is saying, "Go, Rocky, go!" So it's almost time. Does it have time? Will Rocky have enough time? And that is the end. Rocky unfortunately could not read the green light. Oh, it opened. Rocky has successfully opened the traffic light, so this is halfway there to saving the world. To all the Rocky fans, Rocky has done quite good. That's my mom.
So now let's move on to the interview part.
Okay, now we will be moving on to the. All right, we are here with team.
Team 4.
We are here with Team 4, also known as Team Rocky.
Team Hail Mary.
Team Hail Mary. Okay, so first of all, I would like to say I have been reading the comments, and you guys are definitely the people's champion.
Yeah.
So yeah, everyone has been very happy to see Rocky. They're very excited to see Rocky. My mom personally is supporting Rocky, and yeah, as your TA, I saw Rocky go through a lot of iterations, and yeah. So I would like you guys to quickly say what was the biggest challenge in the course and the class. If you all want to take a go, you can go have a shot. So go ahead. All right.
So first to start off, I will just talk about the challenge. I think our biggest issue with the challenge is the time limit for sure.
Yes.
Because Rocky is a little slow, even though we did test and Rocky was actually able to pass through several of the obstacles, but because the time is very short, it's only 5 minutes, we weren't able to actually get enough points, unfortunately.
Because throughout the 8 weeks, we needed to calibrate Rocky so much that given only 5 minutes for the terrain is genuinely realistically not enough for us because we haven't really get to like test a lot of the features in the course itself. But that's why we went through it. That's why.
First of all, I would like to thank every one of our supporters from the beginning. You guys know who you are. We see you, and Rocky sees you. But second of all, and more importantly, one of the most difficult problems we faced during the creation of Rocky was the programming of it, especially the motion of it. Well, since it is a pentapedal robot, it has way different balance, walking motion compared to like other walking patterns, especially since it is a walker compared to wheels. It is more difficult, and we had a lot of trouble with that. But luckily, we were able to make it move by today, albeit a bit slow, but with time, given a little bit more time, I believe that Rocky would have been able to complete the course.
One of our viewers did say, once perfected, Rocky will save the planet. So, and I would like to say one thing throughout this whole course. This course, the obstacle course, as you see, is made for wheeled robots that I've been stating over and over and over again. For walkers, it's very hard. So, true to the movie spirit, maybe you guys were stupid or you guys were brave to attempt a walker robot, but I see that, and every one of your supporters see that, and you guys managed to do a miracle, having a robot like this move in this course with the short amount of time you guys had, and all the obstacles, all the upsets that you guys have had, has been really fun to see. So, do you guys have any closing remarks?
Well, this really was a project Hail Mary for us. It was very fun, and I'll maybe do something similar in the future because this was a really fun project, and I think we all enjoyed it in the group, even though there are very many tough times. Yeah, thank you so much for allowing us to participate in this course, and we look forward to the other robots. So please continue watching the live stream.
Amaze, amaze, amaze.
All right, that's all for Rocky, and now we'll be moving on to Team 5. Okay, everyone, as you may remember, this is Team 5, the Beast, and it seems like the Beast has finally awoken. Right now, the Beast is being teleoperated. They're not trying to do autonomous anymore. So far, through some struggles, but still, the Beast has completely opened the door and now is inching towards the uneven terrain. Will it will it be the end of the uneven terrain or not? Let's see. Or will Beast persevere? And they have successfully completed the uneven terrain, and now they're moving forward to the slope. Let's see how the beast does with this. So the whole idea of the beast was this is a tank, and this was supposed to be autonomously controlled,
Ooh.
where it that did not sound good.
It seems like a part of it has come off and got stuck
Once
inside.
again, we are seeing a robot that has successfully managed to be the same dimensions of the ditch, and it has perfectly gotten stuck inside the ditch. Come on, beast! Everyone is supporting you. So let's see. According to the viewers, the beast is killing it. I agree with you, but the beast doesn't have enough time. Let's see it. Will it kill or will it be killed? That is the question. Now the beast is trying to attempt to flip over the QR code.
This seems to be rather a hard task for most of the teams, right?
They have successfully flipped the QR code over, but they cannot read it because they do not have enough time.
Uh-oh.
Unfortunately for the beast, it seems that the terrain was stronger. We'll be moving on to the interview of Team 5 now, so be seated, everyone.
Okay, so we're here right now with team number 5, the Beast. And how do you feel overall about the course?
I mean, I feel like it was a good course, good learning experience, working on the beast. We definitely had like a lot of times where we couldn't really like focus on the development because we had a lot of like small issues here and there that were kind of hard to solve. But I mean, overall, I'm happy with the result. You know, the the tank tracks, the arm, the yeah, overall in general, yeah, it was fun course.
So initially you wanted it to be automated, right? Why did you switch to a teleoperated style?
Yes, so originally it was gonna be autonomous, and we do have the autonomous code, and at the end, after all of this is done,
after the stage 2 is completed, we do plan on doing the course again, stage 1 again, fully autonomous. We do plan on that. However, one of the Raspberry Pis, the micro SD, got like corrupted, so we basically could only use one of the Raspberry Pis for both the arm and the tank. So therefore, that caused us some delay, and then the yeah, basically we had to redo everything. So we couldn't do stage 1, and then for stage 2, since we have the arm, it's much harder to do fully autonomous. So we are only planning on doing fully autonomous for stage 1. So then for stage 2, since we had the arm and we had all the setbacks with the Raspberry Pi that happened just this morning, so that's why we decided to do fully teleoperated. But hopefully after this, we'll get to do fully autonomous.
Would you say that was the hardest part, or were there any other parts of the course that you struggled with?
I mean, in terms of the hardest parts, um, at least for myself, I worked on the tank. The other two members, which are not here, they're over there, they worked on the robotic arm. So for me, the problems, I mean, at first we were having problems with like the motors, the connections, our connections were wrong. And we were like trying to find out why. We spent a long time dealing with that, but then eventually we solved them pretty like relatively simple fix, I think. And then yeah, basically with the encoders not getting signal and whatnot, then we solved that, and then it was working fine. Originally, it was gonna be just two DC motors, so then we added two extra other DC motors, so now it's total four DC motors. Um, and yeah, and then for the code, the I mean, we spent a long time. I mean, we spent a significant amount of time dealing with the line following code to make it autonomous, which it does work, but like not with the arm, and we need some time to like upload it and whatnot since we lost the Pi. But the that was also a challenge, but it was interesting for sure getting the line follower to work with the camera, and also getting the QR code detection, because we're using two cameras at the front, the line follower camera and the other camera. So the whole process was very interesting.
Okay, okay. Thank you for your contribution. Thank you. So we will now be moving on to team number 6.
Okay, guys, coming back at you with Agent Perry on the field. One of our commentators said Agent P did not show up today. Come on, don't be like that. Perry is trying their best. We have some bad news from Perry's creators. Perry seems to have lost the motor that may let Perry turn around. It just stopped working, and now they're skipping over a few of the tasks to do whatever they can so far. Let's see if Perry can complete this course with all the obstacles set for it and all the obstacles that it got handed without our intervention and gain the hat. The creators seem to be intervening to set Perry on the right course.
I don't know how I feel about that. Oh, some wires came out.
They're gutting Perry on the field. This is quite unfortunate to see. One of our viewers is saying to call a bet. I think these are bets for Perry.
Okay, vet visit is over. Maybe?
No, I think they still need more time with the bet. It seems Perry's visit to the pit has been longer than the course itself. Okay, let's see if Perry can do this. This is the trust fall, and Perry seems to have fallen face first, but still alive,
Still standing.
still standing. Like Elton John said, Perry is still standing.
Okay.
And I think they're just gonna skip all the way over to the rollers now. They're not even attempting to pick up the object. So, quick reminder, Perry has 30 seconds to do whatever it's trying to do now.
Okay, 10 seconds left.
5, 4, 3, 2, 1.
Good
And
job,
that
Perry.
is the end for Perry. That is the end of the road for Perry. Be seated, everyone. We are gonna have a quick interview with Perry's team going on live now. Okay, ladies and gentlemen, we are here with Team Perry the Platypus for legal reasons. It's Perry, I am assuming.
Yeah.
So, first of all, congratulations on completing the course or attempting to complete it. You have completed the class. So, with this, this is the end of your class for Mechatronics Advanced Robotics. So, first of all, I would like to ask you guys, what was the biggest challenge going into this course?
Well, the biggest was probably the locomotion.
Locomotion, yeah.
Yeah, and also probably the wiring as well. We had, I don't know how many times do we have to change the microcontroller?
Six.
yeah, six is microcontrollers you had to change, and the locomotion also got stuck, and also when we were testing during our for our second stage, the motor for our turning also broke. Everything seemed fine, but like it just didn't turn. So yeah, just locomotion and electrical stuff was our most challenging part.
Yeah, so from a third person's perspective, the skipping mechanism that you guys added into this robot is very unique, very interesting, but it also one of the hardest part of this type of mechanisms is it is gonna come slamming back down, and that if your robot is not strong enough, it cannot survive it over and over and over again. But Perry did show up on the field, and Perry did pretty good. So I would like to ask during the intervention, what were you ripping outside from inside of Perry?
There's some cables tangled, yeah, Taka.
Yeah, so I think so it's from so like the cables and the servo motor were pretty long, and I think that got tangled in the gears and the chain, and yeah, we were just kind of ripping those out.
Okay, so during your interview, pre-interview that we recorded last week, what was the obstacle that you guys were most looking forward to, and did you guys overcome that obstacle, or did that obstacle overcome you guys?
Yeah, so in the pre-interview, we said we could probably do the traffic light, but apparently the traffic light did. Yeah, we couldn't even go to it, and I don't think it even worked today.
Yeah, things happen.
Yeah, a lot of things happen, and yeah, it didn't work that well.
That is quite interesting. But also, one of the other mechanisms that you have very unique to your robot is a tendon-driven manipulator. That is different than compared to any other robots that we are seeing today. All of the robots are using either servo motors or just servo motors. It has been servo motors. So Perry did bring another uniqueness into the field with the usage of tendon-driven manipulator system. So what was the idea behind like having this type of manipulator system? Like, did you guys consider making something else, or did you guys just want to do a tender driven system?
Yeah, mostly we just wanted to try to do it, and because we want to, I don't know, I don't think we wanted to, but like we just they just want to use a low amount of servo and motors. Yeah, so and it's also like flexibly placed, and you don't need to place it on the arm itself. Yeah, that's the idea.
All right, thank you very much, Team Perry. You have successfully completed the course. Congratulations to you and your two team members sitting outside of the interview. We will be moving on to the next robot, which is Team 7 Big Boy. Please be seated. Thank you very much.
Okay, the big boy is here right now. We're skipping a lot of stages, but let's try to see if they can lift the object.
So the position of Big Boy has made it so that it is pretty hard for Big Boy to reach the obstacle. Let's see what happens.
They've also seemed to add some physical attributes to it, like the mustache. I think it adds to the big boy personality a lot.
Yeah, Big Boy seems to have hit a growth spurt in between stage 1 and stage 2. Right now, Big Boy is rocking a very curvaceous mustache, something that I want to grow myself, but I can't. Is Big Boy gonna move? I have gotten word from the creators of Big Boy that Big Boy is done. It seems that the brain got disconnected from Big Boy, and with that, it has been shown that the field is bigger than Big Boy.
Thank you, Big
We
Boy.
will be moving on to interview with the team Big Boy. Please be seated.
The motor died.
Okay, we're here with team number 7. This is the big boy team. And how do you feel about the whole course?
It was fun. It was definitely an experience. Although, of course, we're sad that yeah, it broke down, got some little injuries. I think like we tried our best, and we can reflect on this and do better in our next, I guess, robot projects.
I see. So the big boy got a big brain injury from falling. As I see, what exactly happened there? Can you elaborate?
Okay, so we tried to go down the ditch over there. So we were confident it will stick the landing, but since previously, before our second run here, the traction like broke a bit, so it got loose. And I'm guessing that's the main problem. It didn't stick the landing first time. So we wanted to try a second or a third time because we were sure we can make it. But unfortunately, we couldn't. Yeah, it broke down, and afterwards we couldn't complete the rest of the challenges, unfortunately, since I think we could have done a little bit more. Okay, you wanna say something?
But I believe though we have major improvements from the test day even too, right? Even like the last 2 week was pretty intense, but like we even managed to paint, we managed to like fix the drivetrain like over and over again. It was the belt system first, right? And then later on to the chain and sprocket system. So it has been like quite a journey, I guess. Yes.
So what would you say was like the hardest part of creating your big boy?
Can I answer this? The drivetrain, as we said in our interview, yeah, we needed to figure out a lot. Yeah, everything. Basically, our whole main concept was this right here, and we weren't really able to quite pull it off. I guess, yeah.
Thank you for your contribution. Do you have anything to add today?
Of course, I just want to thank my wonderful teammates for their hard work. I appreciate them sticking with me and like throughout this journey. My professors, the TAs that helped us out, and shout out to my dad who's watching right now. Hello, thank you so much. Who always supports me. Yeah, that's it.
Thank you so much. Thank you, Team Big Boy, and we'll be moving on to the next team. Thank you.
Ladies and gentlemen, we are here with Echo, and so far Echo has done everything very beautifully, very smooth. Every bit of the challenge has been done by Echo perfectly. And now Echo is coming to the problem that it faced in stage one, trying to get the door open. the barrier open by reading the green light. Echo is being teleoperated and it has opened the light. It's swimming time. Oh, Echo seems to have some problem with the barrier. Now Echo needs to successfully put down the object inside the square.
Now we just needs to let go.
Let go. They need to let go.
Second try.
And that is the end. And Echo has completed everything in the course in ample time. Perfect. Now we'll be moving on to the interview for Team Echo. All right, we are here with Team Echo. First of all, congratulations on finishing the whole course. Stage 2, you have finished everything. Congratulations and a round of applause from me and maybe also the audience sitting in here. And also congratulations on finishing the whole class as well. I hope you guys learned quite a lot. You guys seem to have been very throughout the course. I noticed that you guys have been one of the most proficient students in this course. So good job. And I'm also noticing a color theme for the team. I feel like I'm underdressed. Okay, so first of all, what was something that you guys were looking forward to in this course? And please tell me more about it.
I think what we were looking forward to in this course itself is the learning opportunities and for us to try out different ideas, of course, with robotics, first of all. And we got to try out a very cool idea, which involved getting inspiration from Martian rovers and actual monster trucks. So I think we got the opportunity to try that out through this course, which we're very glad about.
Okay, so were there any? I know you guys did not have any problems, but were there any obstacle that you guys were scared of?
Well, I think the answer is clear. The traffic light. Because if you guys noticed, of course, in the first stage, we had a bit of difficulty going past that. But in the second stage, I believe we dominated it. And we were able to go past it in less than 10 seconds, I believe. So although it was a problem at the very first stage, by the second stage, we were able to fix it and we dominated.
All right, good job. A round of applause for Team Echo, and we'll be moving onwards to the next team of Team Spinebender. Thank you very much. Okay, right now we are here with Spinebender. Spinebender is so far has done all of the obstacles and now is having a hard time with the LED. This seems to be the hardest part of this obstacle, flipping the QR code in the correct angle to be able to read it.
The viewers can't really see it right now, but the QR code basically is like on a stick, kind of, right?
It is a stick that is constantly, perpetually spinning. If you move it with too much force, it will keep on spinning. That is the problem. It seems that Spinebender skipped the LED and is now moving forward to pick up the obstacle. I gotta say, Spinebender does look very beautiful with all the beautiful colors added to the body.
Okay, we're being very careful right now. Ah!
They seem to just miss the handle of the object.
Okay, the
Seems
wheels
they're
are working.
gonna drag it to a perfect position for it to pick it up. Oh no, it seems they have toppled it over. Can they make it stand up again?
They have 20 seconds left. Okay, the object is left behind and we're moving on the stairs right now.
Spinebender is panicking now, trying to climb the stairs, and it has climbed up. And that is the end for Spinebender. Our champions of stage 1 had a bit of a fumble, and now we'll be moving on towards the interview for Spinebender. Ladies and gentlemen, we are here with Team Spinebender. What happened? You guys were the champions of stage one. What happened? What was the fumble? But before all of that, I will say Spinebender looks beautiful. One of the most beautiful robots on the field. So I'll be giving on to you guys.
Well, we were really happy about our success in the first round, and in the second round, I think we had a little bit of a coordination issue. It was really difficult to see the field through the camera and to coordinate the manipulator to do what it is supposed to. We will blame this on luck a little bit on practice.
Yeah.
But overall, we're really happy. Our robot is functioning. It could overcome most of the obstacles. So
we if we had a little bit more practice and communication between teammates were important, if we communicated more, like I trust me, this robot could have cleared the whole thing.
If we are looking to the room for improvement, I think we should improve on like the communication system, because right now we are facing on like a little bit delay commanding between the guys who see all the fields and the guys who control the robots. It's have a delay around 1 second until 1.5 second. So maybe that delay can cause a lot on our robot's performance. Yeah, we can do negotiation on that, and let's see that we can improve this in the future furthermore, I think.
Thank you so much. But to be honest, the delay from the camera with the operator is part of the challenge, which you guys, when you practiced last week, also faced. But understandable with all the nervous and psych, it is it is pretty hard to on when you're on field. It's very different from when I'm talking from outside. When I took this course, it was pretty hard for me as well. So it was a good show. It was honestly a nice show for the whole robot. It did pretty well. And when you said that this robot could clear this whole field, I do believe that, because it has shown that it could. It just needed a bit more practice. So in your interview, what was the one obstacle that you did thought was going to be a big problem, and was it a big problem going ahead during this course?
in our interview, we were 100% confident. We expressed 100% confidence. I would like to say that this confidence has not dimmed. We're still very confident. We just had a performance issue, but we believe that all the obstacles were passable with our design and control logic. So, yeah, maybe with a bit of more time and practice, maybe our weakness that we should have pointed out was practice, practice time. Yes.
So another thing, everyone looks at this course and thinks, okay, we will make a tank. And that was my first idea as well. But you guys took the tank and gave it a nice bend. I might say, pardon the, yeah, pardon the pun. So what was the idea behind that? Like, what was the idea behind this, this whole design, this whole concept, and what went on leading up to finalizing this as a design?
I can talk about it.
Yeah, okay.
So yeah, of course we thought of a tank, but of course we wanted some creativity. But also we believe that just a tank would not have been enough. I mean, our robot is pretty big, but even the height of our wheels alone would not be enough to go up the stairs or even over a lot of the obstacles. So if we just had one of the bodies, it would fall down the stairs. It wouldn't even make it up the stairs. So that's why our design includes a bend. So we wanted a flexible robot that could kind of crawl over obstacles. And actually, we didn't even plan on an actuator joint, but we thought it would be a good function to be able to raise our robot or to go like concave down on some obstacles. So I think that our robot could take on even like harder obstacles, like physical obstacles as well. Yeah. So that was our thought process. And I still believe, even though it is a tank, it still does not rely on a lot of the things that more classic tanks rely on, like a triangular nose or the size of the wheels. So it is just as much brute force as it is flexibility and design, careful design.
You want to say something? No. All right. Thank you very much once again, Team Spinebender. Beautiful robot, beautiful challenge. Thank you very much. We will be moving on towards Team Team 11. Unfortunately, Team 10 seems to be not able to do it right now, so we will be doing with Team 11. Please be seated for that. Okay, Tomoe from Team 11 has been flying through the course, I might say. Yeah, and they have opened the door as well. They are gonna skip through it because the door closed by it, but they have successfully opened the door. And it seems they're about to finish the course in record time. They just need to place the object down. Can they do it perfectly? And they have done it. Team 11 has finished the course. That is it. We will be moving on with Team 11's interview.
Okay, so we're here right now with Team 11. How do you feel about the overall course today?
Um, First of all, we are very happy that we managed to complete the second round perfectly. On the first round, we have a network issue about the Wi-Fi, but we managed to fix it. And then on the second round, we completed the course fully. Yeah, and we're very happy for this.
Can I ask you about the wheels itself? Because they're some special kind of wheel, right?
Yes, this is a PATS wheel. It stands for the passively transformable single wheel. So as you can see over here, like the wheels are not like intact with each other. So it has the ability to deform like this. So when the wheel deforms, yeah, it makes it easier to go around obstacles and to climb the stairs.
What would you say was the hardest part of the course itself?
Actually, we tested the robot several times in the week 14 and week 13 and the weeks before that, and it was able to complete the course properly. So the main issue today was there was so many robots connected to the same Wi-Fi, so it makes it difficult for streaming the video real time, and then it's also difficult to send the commands for the wheels and the servos. So I think the main issue today was not the robot itself, but from the Wi-Fi.
Also, at first, you wanted to make it automated, right?
Yes, we've been wanting to make it automated. So he even created an MCP. So maybe you can explain a little bit about it.
So actually, we've created the MCP and all of the pipeline for automating, but there were a lot of environmental issues for the round. So this time we just focused on doing it teleoperated.
What does MCP stand for?
MCP stands for Model Context Protocol.
So, do you have anything you'd like to add today?
So yeah, I'm very thankful that as a group we managed to like complete the course together. Like we've been working hard in the past weeks and testing it together, and even having the goal of making it like automation. And yeah, I think as a group we also want to we want to say thank you to the professors and to the TAs who've been like giving out ideas and helping us like throughout the way. So we're grateful in many ways, and it's a very good learning experience for all of us. So thank you very much.
Okay, thank you, team number 11, and we'll be moving on to the next team. Thank you, guys.
Elibot seems to have a very enthusiastic guidance. It's like watching a dad teaching their children how to park. It seems it seems the cameraman has finally listened to the audience and we have gotten a Monish cam. They have flipped over the QR code. Can they read it? Once again, we will know if they have read it if their LED light turns on. We are all waiting with bated breath. Can they do it? And they have done it. It has turned on. LED has turned on. They're using red and green. That's a personal favorite color of mine. Let's see. Last time Elibot fell face first here and died. Let's see if Elibot can survive this.
I think with this spectacular guidance,
Oh
yes,
my god, it
they
has done
managed.
it perfectly. This time around, they had their manipulator standing up and then they backed down into the from the cliff, and it perfectly helped them manage. They're gonna skip all the way in to the back and try to pick up the object from here. I want to preface that Elibot has a minute to finish all of this. Can they do it? We all want Elibot to pick it up. And it is true. They have threaded the needle. Now they all need to do it. And they have done it. Now Elibot needs to move super fast, breeze through the rest of the competition. And they have done that. Now they're climbing the stairs. Can they do it? They have 30 seconds. Go. And they have gone. Turn left. They need to turn left. They have 20 seconds. Can Elibot do it?
It's getting very heated.
It is now to the right. 9 seconds. 8, 7, 6, 5, 4, 3, 2, and they have. That is it. The end for Elibot.
Thank you. And we will now move on to the interview part.
We will move on to the interview. All right, that was Team 12. I'm here with standing with Team 12 with their Elibot. Beautiful, beautiful showcase of talent and skill. Nice control and nice guidance by you. So you guys did pretty well. I want to say this one thing. I've been sitting. Monish, you have been a fan favorite through the comments. And one of the biggest comments that we got, and my first question is, why wasn't the robot called Monish Bot?
Because it's a team effort.
Humble, very humble. Good job. Okay, so in your pre-interview that you did last week, what was the one obstacle that you said was gonna be your biggest challenge, and did you overcome it today?
As you mentioned previously, like the only obstacle that we were really worried about was the stairs, and thankfully we did that. But the issue that we faced this time was the initial latency of the camera in the first stage. Definitely, I do believe we could have gotten a lot higher of a spot in the first stage, and especially we've been working for like so many weeks, 6-7 weeks, and we really thought that we deserved it.
Yeah, I truly feel you. I was really excited as well throughout the whole thing. Your enthusiasm caught on to me, and I was really happy seeing the robot move around. So, any other challenge throughout the whole 15 weeks as a team that you guys faced, or individually that you guys faced that you want to talk about now?
Probably just that we didn't have enough time.
Monish, as always, is being very humble throughout this the whole thing. And I am, as your friend and as your TA, I was very excited to see what you guys did and what you guys achieved. This is not an easy task. You guys definitely did a Herculean task and you have completed it very well. So, congratulations on finishing this obstacle course and finishing the class. And hopefully, you have learned a lot throughout this whole course and you will carry this along into the future. Thank you very much.
Thank you.
All right, please go back. Ladies and gentlemen watching online, we are now going to be going with Team 10. So please be seated and watch that.
So the caterpillar is on the go and currently it's struggling to pick up the object. We have a very interesting system with a hook that looks like kind of a ship crane. Oh, and it just ran over itself. Let's see how it tackles that problem. But it's already doing better than the first round, where the wheels were falling off pretty frequently. So that's good improvement. Also, again, as a reminder, this team is fully Japanese, so they're doing their best, guys. Okay, we have 40 seconds left, and the wheel came off again. Now it's moving towards the stairs. And yeah, the wheel is gone again. There's 10 seconds left.
Can they fix the caterpillar wheel in time to make it back up the stairs? Unfortunately, no. That is the end for Caterpillar Hook. And that is the last robot running this course. Thank you very much. We will be moving on towards the interview.
Uh, so our robot is so not good because we don't have any we don't have time. So we very hard this course. So.
What do you think was the hardest part of it all?
And the most difficult point is uh, uh, the most difficult point is to carry back because our robot arm is hook, but uh, control is very difficult. So yeah. Catching is very difficult.
So the hardest part was making sure the object catches on the hook. Yeah. Did you enjoy the course? Because I think it's hard as fully Japanese team because everything is in English, right? So you're doing amazing. So how do you feel about it?
Yeah, we can feel enjoy during.
Okay. Thank you so much, guys. You did amazing. And now we're gonna wrap things up. Thank you.
Thank you, everyone, all of the combatants and all of the viewers. Thank you for watching this beautiful live stream from start to end. We have finished all the robot runs, and now we are gonna review the score. So, can we move on to that screen? Ready? All right, everyone. I need everyone's focus. Okay, is everyone here? I'm gonna start just as in the last round. I'm gonna start from the bottom. Coming in number 12 is Big Boy from Team 7 with 29 points. Moving on ahead, coming at number 11 is Team 3 Komusuke with 30 points. At number 10, we have Team 1, The Worm with 31 points. And breaking into top 10, at number 9, we have Perry the Platypus with 32 points. At number 8, it is the Beast with 45 points. Coming in at number 7, we have Caterpillar Hook with 48 points. At number 6, we have the People's Champion Rocky with the 54 points. At number 5, we have Spinebender with 96 points. At number 4, we have the Racer with 97 points. And now, at the bronze position, number 3, we have Team Monish Elibot with 105 points. That got a huge cheer from the crowd. At number 2, in the silver position, we have Team 11 Tomoe with 136 points. And now at number 1, edging out number 2 by just 1 point, we have Echo with 137 points. Ladies and gentlemen, that brings us to the end of this event. Please do not turn off the live stream yet. We have Professor Nisar, the professor of this class, with a few words. Right now, I'll be handing the mic over to him.
Okay, and that brings us to end of the KUS Robot Challenge 2026. What a challenge it has been for everyone. Over the last couple of hours, we have watched the effort of our students, 6 weeks effort. Yeah, they put it online and live and in front of all of us. So some robots worked as they were designed and some didn't work. But in both cases, the most important thing for us is that students learn a lot from these experiences. So the student thinking on their feet and under pressure and didn't give up, that's the most important thing for us as instructors. So to every team, congratulations. And you must be proud of your work, and I am proud of all of you, your hard work. And this is not the performance of your robot, but it's the effort of your whole team. You work day in and day out. So it was not easy to make this robot within 6 weeks. That's very challenging. It's very difficult to do with multifunctional robots that can compete in such kind of challenge. So we are very happy with your performance. So the late nights you worked and many redesigns and the feedback you obtained from us, sometimes very tough, paid off finally. Yes, that is part of becoming engineers. So this is exactly the experience this course is meant for, and I hope you have earned it. So a few thanks to several people. Particularly, I would like to thank my colleagues, Professor Sato, for providing a lot of support to the students during the instruction, and to the amazing TAs. Yes. So, including our students and the TAs work more than what, yeah, this course just requires. So, thank you very much for your hard work and team effort. And for everyone on the live stream, thank you for being with us in such a long stream. I hope it was real fun to see the students putting their robots on the real test today. And students, just a kind of final message from my side as you close this class today. This is not the end. Yeah, this is the moment to appreciate how far you have come and the skills you have learned during this course. I hope they will stay with you forever. And congratulations once again to all the teams, irrespective of your grades and final scores from the challenge. So, on behalf of KUS Faculty of Engineering, I would like to congratulate all of you for your achievement and thank you for being with us today. So, with this, we would like to conclude today's session. Thank you very much, and we are looking forward to seeing you next year, hopefully in the same week, with the new challenge, robot challenge for this lecture. So, before we end this stream, our students will put their robots on the field and do a bit of practice because some of the robots are slow. They were not able to complete everything. So now it is time for them to give their robots full freedom to operate in the field. So that's all. Thank you very much.